As we're moving forward now, we are going to be graphing our polynomials. And by graphing, I mean we're going to be sketching them based on end behavior and the behavior happening at each root, or 0. So right now, we're going to be talking about end behavior. How do we describe the graph's end behavior? If we look at a line, okay, we have this line here. Lines happen when we have x to the first power. So if we have a root or a function that has x to the first, it's going to behave like a line. But if we talk about its end behavior, how do we write that? So the notation that we're going to be looking at right now is how we're going to write that end behavior. So if we look here, as we get bigger on the x-axis, so as x approaches infinity, we can see that my graph itself is going to continue up and it's going to go to infinity. So we would say that as x approaches infinity, y approaches infinity. So as x gets really, really big, y is getting really big. So this is my x values going to infinity. These are my y values going to infinity. Okay? Same thing over here. As x itself goes to negative infinity, my graph is going to negative infinity. So as x approaches negative infinity, y approaches negative infinity. All right? Basic terms is x is going left, y is going down. As x is going right, y is going up. But we're going to use this vocab. As x approaches infinity, y approaches what? As x approaches negative infinity, y approaches what? This is the end behavior always for an x to the first, unless it's negative. If we came in and I said, well, let's look at negative x, then it's going to change and it's going to look something more like this. Obviously, those aren't the exact lines because we have y-intercepts, but just the end behavior, how that changes, is now as x is going to infinity, y is going to negative infinity. As x approaches negative infinity, y is approaching positive infinity. Okay, so we do the same thing with our x squareds. But this is going to hold true for end behavior as we look at even x to the 4th, or x to the 8th, or x to the 526th. This is going to hold true anytime we have x to an even power. Again, this is all emphasis on end behavior. So, if we notice with the quadratic, it's going to infinity and to infinity. So as we write that, I'm just going to say, as x approaches infinity, y approaches infinity. So as x goes to infinity, y is going to infinity. We're seeing it go up. As x approaches negative infinity, y approaches infinity. So now as x is going negative infinity, our y is still going to positive infinity. Again, the only thing that would change is if this were negative, then we would see it going negative infinity, negative infinity. End behavior. Okay, and my last one over here is my y cubed, my x cubed. What we see here, this would be true if it was an x to the 5th, or an x to the 7th, or an x to the 831st. Okay, this is all odd numbers greater than 1. Because 1, we already know, looks like a line. But if it's an odd number greater than 1, then it's going to have this buckle appearance here. All right. So we see as x goes to infinity, y is going to infinity. So as x approaches infinity, y approaches infinity. Boom. So I go positive x, I go positive y. We do the same thing. Sorry, I'm just checking my computer. It's gone to sleep. Hopefully it's still filming. As x approaches negative infinity, y approaches negative infinity. So as I come over here and I get closer and closer to negative infinity, my y is going down to negative infinity. Again, if we were to switch that and make it negative, we would see it come in and do something like this. And then these would then change. So that's to show you the notation that we're going to be using for our end behavior and how these values work. So remember, x to the first looks like a line, x squared looks like a quadratic or any even, and then x to an odd power is going to look like an x cubic, where we see the end behavior coming in opposite directions. Okay, we're going to apply that to graphing in our next video.